Ignazio Maria Viola. I work in fluid mechanics, and my specific interest is when you have flow, and this flow makes some turbulence, makes some vortices, and these vortices are affected by the body which is immersed in the fluid. So for instance, if you have a sailing yacht and the flow invests the sailing yacht, it generates forces through the generation of vortices. What do these vortices do? How do we control them? How can we exploit them to design better sails? These vortices are typically used also by birds to fly, or used to by airplanes to fly. So for instance, one example of my research project is we model the flow on the boundary layer on the sea surface, or this one could be actually the channel flow under the free surface. We look at which is the velocity profiles, we look which are the vortices inside the structure, and how these vortices interacts with the turbine, or how these interact with something else. What do I need to do? All right. I'll carry on meantime. So an example that I think is very relevant to you is, for instance, when this turbulent flow is actually interacting with the turbine. So there is vorticity in the flow, and there is vorticity which is generated by the turbine blade. The two vorticities interact and can be constructive or deconstructive. You can actually have this interference might be extremely powerful. What happens, for instance, is that you have these vortices which are generated on the turbine, and these are going to interfere with the vortices which are coming from upstream. Now here you have the blade, and if you move this blade, you can actually try to change these interferences between the two vortices, and you can completely change the flow field. So in this case, for instance, you have a touch of flow in this profile, but on this profile you have this touch of flow will become separated when there are interaction with the vortex. But if you move the turbine blade, you can actually have a touch of flow, you can improve the performance, you can decrease the fatigue load. So here you have a peak of fatigue load, but it can actually be decreased by the effect of the flexibility of the turbine, and potentially you can also increase the lift of the drag ratio, so the performance of the amount of power you extract. Now this can be passive, can be active, can be you can use smart material which actually actuate the blade in such a way that actually you exploit instabilities in the flow, and you can make major changes. Yeah, that's about for me. Thanks.
This production is brought to you by the University of Edinburgh.